So this is ME4111 Statics, and we're working through George Sheet 4. So we're currently on question 5. So we'll just have a look at this question. What we have is something that looks a little bit complicated. It's more typical of the kind of analysis you might be expected to do. What we have is this drill that is acting on this piece of wood, and the bit is making contact at point O. And we're asked to replace the forces shown on this by an equivalent force coupled system acting at this point O. And we're told there to express our results in vector form. Okay, so again, with all this stuff, you should be very, very comfortable working with vectors at this stage, and it should be becoming second nature just to express everything in terms of vectors. Now, the face for this problem looks considerably more complex than the previous ones that we've been looking at, but if you break it down, our approach is pretty much the exact same. We don't really care about the shape of this. All we care about is the point that we're interested in, so point O, and where forces F1 and F2 are in relation to that. So if we start to work through our solution, what we have is, again, the same process of step 1 being the translational effects and step 2 being the rotational effects. Again, the translational effects is concerned only with forces. So our resultant force is simply the sum of the two forces. And if we look at these forces, we've got F1 is expressed in terms of its I hat, J hat, K hat. And F2 is also expressed in terms of its J hat and K hat. There's no I hat term. So what we do is we simply relocate these two forces down to point O, and we add the two of them together. So we have 2 J hat minus 4 K hat, so that's the F2 force. And then we have the 6 I hat minus 3 J hat minus 10 K hat, which is the F1 force, and we add the two of them together. And also when I'm writing these, that I put brackets around the forces, just so that it helps me remember that these are in fact grouped together in a force. So we add up the I hat terms, so 6 I hat, J hat, it's 2 J hat minus 3 J hat, that gives us minus 1 J hat. And we've minus 4 K hat and minus 10 K hat, that gives us minus 14 K hat. And our units then are newtons. Okay, so that gives us the resultant force acting at point O. Step 2 then, as we've had previously, is the rotational effects. So now we're taking moments. We first of all do a check, neither of these are coupled. So we've got to take moments. And because it's a 3D problem, we simply use the vector cross product. So we have, again, a vector notation, the moment about point O. So the rotational effects caused by these two forces. We first of all take F1. So I'm labeling this point here. That point there is A. And I'm labeling the point where this is as point B. Okay, so I have ROA cross vector F1. So that turning effect plus ROB cross F2. So first of all, I want to figure out, well, do I have ROA and ROB? And I don't, so I need to work those out. But from inspection, from the geometry I'm given, I can easily work these out. So again, how do I do that? I start at point O, and I want to get to point A, which is up here. So how do I do that in X, Y, and Z? Well, I got to come out this far in X, so that's 0.15 meters. I don't go anywhere in the Y-axis. I'm already underneath it. And I come up then 0.3 meters in the K hat direction, the plus Z direction. So ROA is 0.15 I hat plus 0 J hat plus 0.3 K hat. For ROB, again, I do the same thing. I want to get from here up to this point up here. So how do I do that? Well, first off, in the I hat direction, I don't go anywhere. Then I look at the J hat direction, so Y, and I got to go back this distance out to here. That distance we can see is 0.25. So again, it's minus because the plus y-axis is out this way. So we have 0 I hat minus 0.25 J hat. And the last thing then is I need to come up to the point there, and that is the 0.3 meters. So again, that is the plus Z direction. So I got plus 0.3 K hat for that. Okay, so if I look at this now, I already know what F1 is. I have that. I have F2. I have ROA and I have ROB. So I can now evaluate these cross products, figure out what the moment is about 0.0. So again, I'm just going to use the determinant for this. We've got 0, excuse me, the moment about 0.0. So we've got I hat, J hat, K hat, 0.15, 0, 0.3. So again, if we go back, that is, this is the ROA term. Okay, so that is coming in there. And the force then is 6 minus 3 minus 10. And again, it is this force here. So you can see that it was useful to bracket those out there. So 6 minus 3 minus 10, which is the force F1 acting at that point. Likewise, then I have here, I've got the 0 minus 0.25, 0.3. So again, that is this. And my force then is a 0, 2 minus 4, which is this force here. Okay. So I simply evaluate that determinant. Again, that's just the mathematics of it, and that's something you expect to be able to do. And I get my answer then for the moment as this 1.3 naught I hat plus 3.3 naught J hat minus 0.45 K hat Newton meters. Okay, so my answer then is my resultant force. So 6 I hat minus 1 J hat minus 14 K hat Newtons at 0.0. And my moment is 1.3 I hat plus 3.3 J hat minus 0.45 K hat Newton meters. Okay, that concludes that question. I hope you found it useful, and we'll see you.